All right, folks. Now, before we move on to question 6, now let's just continue where we left off with question 5. So, what happens is that the thing that I used for recording videos only allows for 30 minutes videos. So, for that case, the off I was forced to take 5.5.2 to the next video. All right. So now let's remember you have already done this. Now, let me remind you, we are saying sine 4x it is not equal to 2 because now the sine graph has an amplitude of 1 to -1. So it is above this one. 2, it is above, okay? So there's no such graph unless here it is 2, okay? Yes. Now, they say to us, hence, let me do this. Hence, determine the general solution of x in the equation 3 tan 4x, blah, blah, blah. All right, remember we have already found these values, right? So it means now you're going to only use this one, okay? Because it is the one that is a, that has a what? That has a solution, okay? So the general formula, sorry, the general equation, how are you going to do that? You're going to say now you have sine 4x, all right? Now, what you first find, it is your reference angle. What is your reference angle? You just say, this is sine, right? Just say arcsine of just half. Just take half, okay? This negative sign, we're going to use it somewhere. Save it, okay? Save it for somewhere. We're going to use it. Now, sine half, it is how much? 30 degrees, okay? Inverse, all right? The arcsine, which is the inverse, okay? You just say shift sine rather. Shift sine of 0.5, which is 30 years. Then now you say, now you take this negative sign and say, now where is sine in negative? Sine is negative. Remember your cast. It is in quadrant 3 and quadrant 4. Okay, so you're gonna say, okay, let's go to quadrant 3 as well as quadrant 4. It is where we find our sine as negative. Okay, so what are we gonna do when we arrive there? When we arrive there, you write this angle as it is. As it is how much? 4x, it is equal to, on quadrant 3, what do we say? Remember, you say 180 plus the angle. So in here, we're going to say 180 plus, what is our angle? Our angle is this one. 30 degrees plus what? K, 360. Remember, K is an element of integers. Now, if you're still wondering why we use 360, it is because now our sine graphs takes a period of 360, all right, to complete its wave. Similarly, we're going to do the same thing here. 4x, it is equal to, but in this quadrant, we say it is 360 minus the angle. So it's going to be 360 degrees minus 30 degrees plus k 360. Remember, don't forget that k is an element of integers, right? Remember, integers, it is done like this. But even if you just say integers, it's fine. Okay? Now it's just a matter of simplifying 4x. It is equal to 210 here plus k 360 degrees now. Then it's fine if you do not continue with k as an element of integers. You already stated that 4x, it is equal to 330 now plus k 360. Now let's simplify. Divide everything by, I said everything, by 4. So it's going to be 210 divided by 4, which is going to be 52.5 degrees plus k. Now also the 360 also divide by 4, okay? It's going to be plus k 90 degrees, okay? Then x, it's going to be 330 divided by 4. It is 82.5. Let me rewrite that. 82.5 degrees plus k times 90 degrees, okay? Yes. So this is our general solution thereof, okay? Now there is a difference between general solution and specific solution. Specific solution, it is when you are given the interval. Let's say they said x should be in an interval 0 to 90. This is what we call a specific solution. So you're going to say, okay, find all the values that fall under that equation. So the first one that I can see, it was 52.5. When I say k is equal to 0, it is this only one. The answer is only this one, right? When I say 1 here, when I input 1, is going to be 90 plus. This one is going to be more. Negative 1 is going to be negative 90 plus. This is going to be less than 0. So we move on. We come here. When we insert 0 here, is going to be just 82.5 degrees. When I set 1, it's going to be more than that. When I say negative 1, it's going to be less than negative into less than 0. So it was going to be only these two. Now I want us to move on to question 6, which is trig functions thereof. Okay, I want us to move on to trig functions. Okay, I'm giving that in the diagram below, the graph of f of x, which is tan x minus 40, tan into x minus 45, is drawn on the interval negative 90 to 180. I want you to see this. Remember, this is shifted. Negative means shift to the right, 45 degrees units. So it means if my graph, everything of my graph should shift to the right. What do I mean? Remember the tan graph, it is like this. Let me just draw the normal one. Okay. It has an asymptote at 90, asymptote as well as at 270. So it means now that it is shifted like this, shift to the right. So it means now each and every point that if this is like this, my graph is supposed to be looking like this again. Every point you will move to the right. So meaning from this asymptote, it will move to the right 45 units. It means I'll have a new asymptote at whatever that coordinate is, and another one at whatever that coordinate is. I want to believe you are following. Sorry, let's now do a practical. I'm saying for a normal tan, this is supposed to be our uh, our what? Our asymptote here, right? At 90. But now it is shifted. Remember, when we deal with functions, when you say x minus something, minus means you move to the right, plus means you move to the left. So can you see that it is shifted 45 units to the right? Now, 90 plus 45, it is 135 thereof. Similarly, it was supposed to be here at negative 90. Okay, now it shifted 45 degrees to the positive, which is negative 45. Can you see that? I believe you are following. I hope you are following. Now let's try to answer the questions that follow thereof. Okay, write down the period of f. Now, the period of f, remember the graph of f, the graph of f, the graph of f, always has a period of how much? Always has a period of 180. Now remember, sine and cos have the period, has or have, I don't know which one to use. I failed English with level 6. So the period of tan, let me talk period. Cos and sine, always, not sometimes 360. But tan, it is how much? 108. Whether this, even if they ended it here, let's say they ended it here on this portion here on the 90 part. For the factor, it is a tan graph. It was gonna have, it is gonna still have a period of how much? 180. That one is a very straight one mark that the examiner tried to boost you with. Draw the graph of g of x. It is equal to negative cos 2x, blah blah blah. Before I draw that, I want you to show you this equation. Remember the normal one, it is sine x, okay, plus q from grade 10. Where this, you have an amplitude of 1, then this is just a shift, a vertical shift, whether it is going up or down, right? Now, we used to draw a graph like this and say we have an amplitude of 1 and negative 1, right? But now, as we get advanced, we now change our equation to a, here it was a, okay, a sine x minus p plus q. Actually, there's something missing here. Actually, let me not include them at once. Y is equal to a sine x minus p plus q. I say this is the vertical shift. It either goes up or down. But this is your horizontal shift. Now it no longer moves whether from here to just that but it now has the capability to do this, to move from this point and start somewhere here. Can you see now? Let me redraw that. It starts here. So now the coordinates have shifted. Can you see now from this point it has moved towards the right, okay? This is what the x minus p does. Where when it is minus, it moves to the right. When it is plus, it moves to the left. Then, if I do not talk about this one, there is this one that y is equal to a sine b bx. Now, before we had x, but now we have bx. Now, I normally call b the period affector. Period affector. Why do I call it a period affector? Because now my graph, let me say new period. Sorry, new period is gonna be old period divided by period affector, which is b. Now, remember for sine graph, the period it is 360, but divided by b, it affects the period. Now, if I'm having sine x, the period is going to be how much? 360 degrees. Why? Because I'm having something like this. Okay? This is 360. But if I were to have sine 2x, it's going to shift my, it's going to narrow down my period to 180. Why? Just divide by b, which is our period affector. Can you see that? This is our b. Okay? This is our b, our period affector. Just divide by that b, it is 2. You get how much? 108. What if it was half? What if it was half? It's going to narrow it to how much? 720. Sorry, why? Why? Because now when I say 360 divided by half, it's going to give me 720. Do not cram this. Use this technique. It is not necessarily a formula, but it is just a technique that I use to remember these things, okay? New period is equal to old period divided by period affected, the B. Okay, yes, I believe I explained what I wanted to explain. And similarly, if I'm having my sine graph like this, if I'm having my cos graph like this, remember it starts from 1 to that. When I say negative cos x, what changes is just the shape, okay? Not necessarily the shape, but where it starts, it will start at the here and do this. Instead of facing upwards like that, it will rather do that. Yeah, I believe you are following. I believe you are following. Now let's move on and answer the questions. Okay. Now they say to us, draw graph of G shifted. Ah, we are not there. Draw the graph of G of X. It is equal to that one in the interval, blah, 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 on the grid given on the answer sheet. I'll use this one, okay? Now, negative cos 2x. Now, I normally do, I do this sketch like, okay, if this was supposed to be, let me say this is negative 360, 180, 0, negative rather, 180, 360. It was supposed to be something like this, okay? I'm lying more. Something like, yeah. But now, what happened is that it has a turning point at 180. Can you see now I have a what? 2x. Okay, that 2x, it is a period effect. Okay, but now I have a negative, so it means now my graph will shift to be like this. Okay, it still has an amplitude of 1. Okay, now what I will do now, I will, okay, what I normally do, you can do this, it's fine. It's fine. Just use a table method because, yeah, choking won't help. Okay, let me just use find a space where I can do my table. Oh, I'll just say x and y. Okay, remember it is negative cos 2x. Remember the x that I have, it is negative. These ones, I'm gonna just include these ones, all of them, okay? Because I'm writing that in that interval, negative 90, negative 45, 0, 45, 90, 135, 180. Okay, I'm gonna need those points. Now you can punch your calculator and say negative cos 2 multiply. You're gonna say inside the bracket, it is 2 multiplied by what? By negative 90. By negative. I'm gonna already plot my coordinates there, that those are that I get here already here, so that I can not waste any time. Ne? So negative 90, it gives me something like 1. Negative 90, it is 1. Okay, I plot. When I use negative 45, how much do I get? Negative 45, 0. Okay, when I say 0, when I say 0, oh, I said 45, okay, it gives me 0. When I say 0, it is negative 1. Sorry. Negative 9, negative 91, negative 45, 0 here, sorry. Then 0, negative 1 here, yes. Sorry about that. Then when I punch 45, it is 0, 45, 0, 45, 0 here, 90, 90 it should be 1, I believe. Let me just confirm if it is not negative 1 or positive 1. Then 135, 0, 135, 135, where is it? 135, 0. Okay. And 180, 180, negative 1. This asymptote, it is the asymptote for the drawn graph already, not the graph that we are supposed to draw. Now, how can I join that? Remember, I'm expecting something like, actually the graph, since well it has a negative sign, it's supposed to be something like this. Okay. Oh, but now remember the period, it is no longer 360, it is 180, because now this is 2x. Remember, if this is 2x, when I come back to that formula, sorry, I removed this. I'm gonna say the normal period divided by the period of vector, which is 2. So it's gonna be looking like this. Uh, like this, but it will end here at 180. Okay, full wave. Then here it will just do at the turning point. Remember now the turning point is now 90. Okay, the turning point is now 90. It means also the turning point here, it is negative 90. So I'm expecting something more or less of that shape. Let me try to execute that. I tried. This is how I was expecting my, sorry. Okay, yes. So yes, that is my graph. That is my cos graph, negative cos 2x graph rather. Now I'm in a position of answering the questions thereof. Oh, they now say to I'll show all the intercept with the axis. Okay, already this one, they are there. You have already shown them from the sketch. Now, as well as the minimum and maximum points. Remember, those are the turning points. You'll just say here, this is negative 90 and 1. Okay, remember this is x and y. Okay, Another turning point again. This is not a turning point. Or minimum and maximum, right? You'll just say this is 0 degrees and -1. Another maximum here. Actually, this is not a maximum, but yeah, it's fine. Just name it like that. Uh, Even if you don't name them, Shem, this is one. Yeah, let's just leave them. This is 19 1 and what? Yeah, it's fine. I mean, the sketch already shows you here. Can you see? Yes. Now, write down the range of G. Range, remember range, it is Y included minimum to maximum. Always, not sometimes. So let's just execute that is an element. So you'll just say y is an element of what is our minimum value? Check our minimum value on our graph. It is -1. Okay. Maximum value on our G graph. G it is the cost graph, remember, okay? So it is -1 to 1. -1 minimum, maximum it is 1. Or you can just use this interval. -1 and 1. Okay, it's fine. That's also fine. Let's move on to the graph of G shifted 45 units to the left. Remember I said 45 units to the left you add. Okay? Left, it means you add. Alright? So when we write that, oh, or to form the graph of H, so it means the graph of H of X, it is equal to G of X. But now what happens to that G of X shifted to the left? Remember to the left it is plus 45 degrees. So let's get the exact H of X. H of X is going to be negative. What is cos G of X? Negative cos into, oh, cos 2 into, okay, that 2 we leave it outside, then we're going to say X plus 45. They say into its simplest form. Then now let's simplify it a little bit further. It's going to be H of X. It is equal to negative cos uh, something like when I multiply out it is 2x plus 90. But can you remember what is this? This is the same as saying this is cos x plus 90. Remember when you add, the order does not matter. It is 90 plus x, which is how much? Remember cos 90 plus x. Remember I said it is on this quadrant. 90 plus on this quadrant, and cos is negative, so it's going to be negative sine x. But in this case, it is negative into negative what? Negative sine 2x, like that. So the answer it is positive sine 2x. Okay, answer positive sine 2x there. Let's write that sine 2x. Now they say for use the graph, okay, the graph that you've drawn on this interval -90 and 90. When I go to my function, I'm gonna cut everything that comes after this part. I'm gonna just stop here with everything, okay? Whatever the value that I'm gonna get, I have to get them in this region, okay? Between -90 and 90, they're off. Now they say where f of x is greater than 1. F of x is greater than 1. Where is f of x? F of x, it is my what graph again. Okay, let me ignore this part. F of x, it is my tan graph. Where is it? Where is it greater than 1? I'm gonna see here from x, this position, right? It is greater than 1. Then let's see other positions. Okay, here, but can you see it is out of region? Yes. So you're gonna say it is just -90. Let's see. Let me greater than 1. Greater than 1, greater than 1. This position, let's see. Let me read the question. For which, where f of x is greater than 1. F of x, okay, is greater than 1. Then -90. Okay, so from this point to this point, can you see that it is above 1? Yes. So you're gonna say now the answer It is x, it is between. Did you see that? X is an element of between negative 90. Do not include 90, because now why? At 90 it is exactly 1, okay? So it is negative 90 to what? Negative 92 to negative 45. Negative 45 degrees. Between this boundary D, between these points, it is a greater than 1. Okay? Yes. Then now, where is 2 cos 2x minus 1 greater than 0? What is that graph thereof? Now, what I normally do in this case is thereof, I see if there is a graph that looks like this. No. So this one it is this, okay? Negative cos. This one it is sine x, 2x, I mean. That is one it is this, okay? What I do it is I try to make it to become like one of the equations that I have, either this one, that one, or the tan one. So I can see I can leave cos 2x on its side, like cos 2x, it is greater than 1 divided by 2. Let me show you how I did that. Basically, I said cos 2 cos, okay, 2 cos 2x is greater than 1, then cos 2x is greater than 1 divided by 2. But now can you see I have negative cos instead? So I'm just divided by negative. What I'm doing here, it is nothing wrong. It is still the same thing. Okay? Okay? Then now I can answer this question. Where is negative? What is this? I can answer this question by saying now, the examiner is saying to me, where is g of x greater than negative half? Can you see that? Yes. Let's answer that quickly. Where is g of x greater than negative half? G of x greater than negative half. Here at this point, you should know that point exactly where it is equal to a negative half. It is 30. Negative 30 somewhere at 30. Okay, why am I saying 30? Because now remember, a cos 2x, it is equal to half when, okay, actually let me say cos 60, it is equal to half. All right, but now I have cos 2 times that angle, which is equal to half. So hence I'm saying my angle, it is half. 30, I mean. So this region there, it is 30. So where is it a greater than negative half? Now can we see that from negative 90 to negative 30? Oh, sorry, where is it greater or greater than negative half? Here's negative half, right? Here's negative half. So it's gonna be greater going upwards thereof. So I'm gonna say oh, sorry, I have to change this sign. I have to change this sign because now I divided by negative, okay? I have to change this sign. So when I divide by negative 1, I have to change that sign. So less than should be this region. If this is a half here, so it means, can you see that from this portion, it is less than half, okay? But that one, it is greater than half. So it should be between negative 30 and 30. X should be between negative 30 and 30 and should not touch, okay? Should not be included thereof. All right. So yes, that's all. Thank you very much, folks. Until we meet again on question 7. Thank you.